Homomorphic encryption allows you to do computation on encrypted data. That's great. Now, what does a blockchain do? A blockchain allows you to do authentic computation on public data. The authentic computation is that the smart contracts are agreed beforehand, and the data is authentic in that we know it's replicated correctly over the blockchain. Authentic public information means the data on the blockchain is in the clear. On the other hand, with homomorphic encryption, we can encrypt that data. So if we can combine homomorphic encryption with blockchain technology, we can solve all sorts of problems that the blockchain ecosystem has. My name's Nigel Smart. I am the Chief Academic Officer at Zama.
This is Code Story, a podcast bringing you interviews with tech visionaries.
Like 6 months moonlighting.
There's nothing at the back end.
Who share what it takes to change an industry.
I don't exactly know what to do
took
next.
many goes to get right.
Who built the teams that have their back.
The company is its people.
The teams help each other achieve. I was proud of our team.
Keeping scalability top of mind.
All that infrastructure was
Yes, we've been fighting it as we grow.
Total waste of time. The stories you don't read in the headlines.
It's not an easy thing to achieve, mind
Took it
you.
off the shelf and dusted it off and tried it again.
To ride the ups and downs of the startup life.
You need to really want it. Not just about technology.
All this and more on Code Story.
I'm your host, Noah Labhart, and today how Nigel Smart is helping to build an open source cryptography company, enabling you to use fully homomorphic encryption. This episode is sponsored by Speakeasy. Grow your API user adoption and improve engineering velocity with friction-free integration experiences. With Speakeasy's platform, you can now automatically generate SDKs in 10 languages and Terraform providers in minutes. Visit speakeasy.com/codestory and generate your first SDK for free. This message is sponsored by QA Wolf. QA Wolf gets engineering teams to 80% automated end-to-end test coverage and helps them ship 5 times faster by reducing QA cycles from hours to minutes. With over 100 5-star reviews on G2 and customer testimonials from SalesLoft, Drata, and AutoTrader, you're in good hands. Join the Wolfpack at QAWolf.com. Nigel Smart is from Britain, but currently lives in Belgium. He has a PhD in mathematics, but headed into the world of cryptography early on. He has started a few companies in the past, both of which have successfully exited, one to Coinbase. But outside of technology, he loves to cycle and attend concerts. When asked about food, he said he loves all food, as long as it doesn't include eggplant. Very early on, Nigel got involved with one of his current ventures. As an advisor, he started to spend more and more time with the company, supporting it through its many iterations, and building next-level encryption for application builders, and doing so through open source. This is the creation story of Zama.
Zama was founded in Paris about 4 years ago by Rand Hindi and Pascal Palia. Rand had been a serial entrepreneur. He just had an exit from another company doing AI, private AI. And Pascal Palia is also a kind of serial entrepreneur, but very much a cryptography head. And he'd been investigating something called homomorphic encryption. Now, homomorphic encryption, there's a very old scheme, actually due to Pascal Palia, called Palia encryption scheme. So it's actually named after him. Been around for a long time, but Palia encryption doesn't allow you to do too much. It allows you to compute some functions homomorphically. I'll explain what that is in a minute. At the point of founding Zama, it was clear that you could do a lot more. So what is this technology? What homomorphic encryption allows you to do is you can compute a function within the encryption. For example, I could give you the encryption of a value 3 and the encryption of a value 5, say. And with a homomorphic encryption scheme, we can then compute the encryption of 3 plus 5, which is the encryption of 8. But the person doing that operation doesn't know the number 3, doesn't know the number 5, doesn't know the number 8. All he does is he knows that he is computing the sum of the values. Now, that's exactly what Palia encryption does. It allows you to compute additions. And you can use that for example, electronic voting. If I'm computing an election, I have a vote for Trump and I have a vote for Harris, and I want to compute the total number of people who have voted for Trump and the total number of people who have voted for Harris, then that's just computing a sum. So with homomorphic encryption, like Palia encryption, I can compute sums, so I can do things like electronic voting. However, if I do something which is called fully homomorphic encryption, I can not only compute sums, but I can also compute products. So going back to my example, I've got the encryption of 3 and I've got the encryption of 5. Then some other party can compute the encryption of the product, which just turns out to be encryption of 15, even though they're not actually knowing what they're doing. And once you can do additions and multiplications, it turns out you can compute anything, because anything can be reduced to additions and multiplications. I got involved very early on when Rand was in his previous company, which his previous company was called Snips, and I was working with Unbound Security. We actually had a meeting in Paris where we had a lunch, and Rand suggested, his next startup's going to be in privacy and cryptography. And I went, that's interesting. And then at the same point in Snips, he was working with Pascal on some stuff with Pascal's other company. And so then as soon as Pascal and Rand formed Zama, I'm not quite sure how many months later, but a few months later, they phoned me up and said, hey, do you want to be an advisor? And I went, yeah, okay, I'll be an advisor. So I was brought on as an advisor. And then over time, I've been spending more and more time with Zama as they're doing rather cool stuff. Then they had to give me a title. So they gave me the title of Chief Academic Officer, which is a kind of silly title, but it was because Chief Cryptographer and Chief Scientist had already been taken. So because I was at that point an academic, they thought, Chief Academic Officer makes sense.
Tell me about the MVP for Zama, that first version of the product that was built. You were involved very early on, so I'm sure you were a part of this process. How long did it take to build, and what sort of tools were used to bring it to life?
In some sense, what we do is we enable developers to build product. While that's changing over time, the original kind of thought process was we're building tools to enable others to build end applications. The main things that were first built were a Rust library, which implements the form of fully homomorphic encryption that Zama uses, which is something called TFHE, Torus Fully Homomorphic Encryption. So that's useful for developers who want to use Rust to build application. But one of the points where this kind of technology would be used is in processing statistical data, doing machine learning, doing AI. So alongside the Rust implementation, another library stroke system was developed which allows data scientists who are used to Python-style programming to turn their Python-style, PyTorch-like programs written in Python into encrypted versions of those programs. At the beginning, there were two dual kind of MVPs. One was a Rust library to enable developers to build on Rust, and another which was to enable more data scientists to build applications. So that's the two initial MVPs. And to then enable that, we created a developer community and tried to get as many people as possible to use the technology by open sourcing it, having webinars, having meetups, having all sorts of different activities, which kind of bring people into the ecosystem so developers in companies can play with the technology themselves and see how it's going to be used. But of course, that's the first initial product. And of course, as time gone on, we've now got other products and ways of working directly where we're actually building applications directly for companies.
Let's stay on those MVPs right now. Tell me about maybe a decision or two you had to make with those MVPs. How you approached the problem, maybe how you limited your scope in early days, or even technical debt acceptance, things like that. But how you worked through those decisions and how you coped with them.
So the first decision is why Python, why Rust? Why Python is very clear that if you are wanting to do a MVP to demonstrate to people who are data scientists, most data scientists now program with Python. So having something that's Python-based is a kind of key if you want to onboard developers in that kind of ecosystem. Another side, so why Rust? The reason Rust is because Rust is now taking off because of its safety, because of the inherent features that it has. It has almost the capabilities of C++. C++ has slightly more due to its age and the standard template library, but that's changing over time. But it has much better safety features, borrow checker in Rust, etc. So we can write more secure code easier in Rust. In some sense, the security community is currently going through a transition from C++ into Rust anyway. So we're riding that wave or leading that wave.
This message is sponsored by SnapTrade. Link in user brokerage accounts and build world-class investing experiences with SnapTrade's unified brokerage API. With over $12 billion in connected assets and over 300,000 connected accounts, SnapTrade's API quality and developer experience are second to none. SnapTrade is SOC 2 certified and uses industry-leading security practices. Developers can use the company's official client SDKs to build investing experiences in minutes without the limitations of traditional aggregators. Get started for free today by visiting snaptrade.com/codestory. This episode is sponsored by Speakeasy. Whether you're growing the user adoption of your public API or streamlining internal development, SDKs can turn the chore of API integration into effortless implementation. Unburden your API users from guessing their way around your API while keeping your team focused on your product. Shorten the time to live integration and provide a delightful experience for your customers. With Speakeasy's platform, you can now automatically generate up-to-date, robust, idiomatic SDKs in 10 languages and Terraform providers in just a matter of minutes. SDKs are feature-rich with type safety, auto-retries, and pagination. Everything you need to give your API the developer experience it deserves. Deliver a premium API experience without the premium price tag. Visit speakeasy.com/codestory to get started and generate your first SDK for free. So then you've got the MVP, you're getting some traction, you're happy with it, you're ready to press it forward. How have you matured it over time? This is what you were mentioning earlier. How have you matured it, progressed the product, progressed the platform? And I'm curious about how you at Zama build your roadmap. How do you go about deciding what is the next most important thing to build or to address?
We have these two MVPs, the Python and the Rust. We then saw that there was an opportunity for us to build another MVP that would be immediately usable by organizations. So this brings us on to blockchain. What does homomorphic encryption do? Homomorphic encryption allows you to do computation on encrypted data. That's great. It allows you to secure data that would otherwise be public. Now, what does a blockchain do? A blockchain allows you to do authentic computation on public data. The authentic computation is that the smart contracts are agreed beforehand, and the data is authentic in that we know it's replicated correctly over the blockchain. Okay. They both got disadvantages. Authentic public information means the data on the blockchain is in the clear. So if you put data on the blockchain, it's in the clear. If, on the other hand, with FHE, homomorphic encryption, we can encrypt that data. So if we can combine homomorphic encryption with blockchain technology, we can solve all sorts of problems that the blockchain ecosystem has. For example, if you're talking to financial institutions, they're not going to want to use public blockchains, even in a semi-private manner, like sharing a blockchain between 3 banks, if they have to put all their customer data on the blockchain. If they could put encrypted versions of that data on the blockchain and then enable computations on those encrypted values using homomorphic encryption, then one of the barriers to widespread adoption of blockchain in, say, for example, the financial services industry is removed. We saw the opportunity of combining blockchain technology with homomorphic encryption. So we built on top of our MVP, which was the Rust library. We then built what we call the FHEVM, which is the addition to Ethereum, which takes Ethereum and allows you to write smart contracts using the Solidity language to manipulate encrypted values on the blockchain. So that was an obvious extension. So we spent a lot of time over the last 18 months building that, and in building the surrounding infrastructure. So it's not just a case of you encrypt data. We could do that with the Rust library. Now what we have to do is we put it on the blockchain, and we have to enable developers on the blockchain to manipulate it using Solidity. So in some sense, that's very much similar to what we were doing with Python and machine learning. The data scientists, they use Python, so we use Python. Blockchain community, they use Solidity, so we use Solidity. Then we have another piece of the puzzle, which is that we have to get encrypted data back into clear text, because encrypting something into the void is pointless. At some point, you want to decrypt it, or someone wants to decrypt it. So then we have to build key management systems which allow authorized parties, to access the encrypted data. So there we kind of use, which is one of the things that I was contributing to a lot. Next, in Unbound, we were building key management systems. It's doing a similar thing, and it's using a technology called multi-party computation to execute the key management system. So to summarize that, we had an MVP, which was Python thing for data scientists. We had the Rust thing for normal computer science developers. And then we built, on top of the Rust, we built a Solidity interface to allow people to do homomorphic encryption. That creates a product that we can use within the blockchain environment. But on top of that, we need to do a key management system to manage the keys of the homomorphic encryption scheme, and that we use multi-party computation. So now we're looking at, we've got a blockchain product, we've got a key management product, we've got a Rust library product, and we've got the Python thing for data scientists. So we have, so there we have like 4 different products already.
You know, as you're doing something as bold and as complex as what you're building at Zama, you have to have the right team in place. So how do you go about building your team, and what do you look for in those people to indicate that they're the winning horses to join you?
There's a lot of expertise we need. For example, there's areas I haven't even touched on yet. To make this thing really fly, we're going to need hardware acceleration. So we also need hardware engineers as well. I would say, I think we've got between 70 and 80 people working for the company at the moment, probably about 75-ish. It changes on a weekly basis. And around half of those have PhDs. So around half of the people working for the company are really domain experts in their area. So we've got a lot of domain expertise. About half the company is at PhD level. How do we recruit these people? A lot of it's word of mouth. In the space, Zama is really well known. In the cryptography space, and especially in the homomorphic encryption space, Zama is probably one of the go-to companies. So we get a lot of people applying because they just know our name. In the blockchain space, we're also now picking up really good brand recognition. So we're getting a lot of incoming people wanting to work for the company. And so then the question is, how do you select? How do you down select? How do you choose the right people? I think we're really lucky in that our teams are really good. We've got really good spirit between working attitude in the teams. The way we ensure that is in the recruitment process. In the recruitment process, we spend a lot of time concentrating on, is the person a good fit for the team? Can the person deliver technically, but can the person also deliver in some sense socially as well? Are they a good fit for the team? Do they work well? Are they going to add something that we don't currently have?
This episode is sponsored by Vanta. You're a startup founder. Finding product market fit is probably your number one priority. But to land bigger customers, you also need security compliance. And obtaining your SOC 2 or ISO 27001 certification can open those big doors. But they take time and energy, pulling you away from building and shipping. And that's where Vanta comes in. Vanta is the all-in-one compliance solution helping startups like yours get audit ready and build a strong security foundation quickly and painlessly. How, you ask? Vanta automates the manual security tasks that slow you down, helping you streamline your audit. And the platform connects you with trusted VCSOs to build your program, auditors to get you through audits quickly, and a marketplace for essentials like pen testing. Join over 8,000 companies, including many Y Combinator and Techstars startups who trust Vanta. Simplify compliance and get $1,000 off at vanta.com/codestory. That's VANTA.com/codestory. This message is sponsored by QA Wolf. If slow QA process is bottlenecking your software engineering team and you're releasing slower because of it, you need a solution. You need QA Wolf. QA Wolf gets engineering teams to 80% automated end-to-end test coverage and helps them ship 5 times faster by reducing QA cycles from hours to minutes. With over 100 5-star reviews on G2 and customer testimonials from SalesLoft, Drata, AutoTrader, and many more, you're in good hands. Ready to ship faster with fewer bugs? Join the Wolf Pack at QAWolf.com to see if they can help you squash the QA bottleneck. This message is sponsored by SnapTrade. Link in-user brokerage accounts and build world-class investing experiences with SnapTrade's unified brokerage API. With over $12 billion in connected assets and over 300,000 connected accounts, SnapTrade's API quality and developer experience are second to none. SnapTrade is SOC 2 certified and uses industry-leading security practices. Developers can use the company's official client SDKs to build investing experiences in minutes without the limitations of traditional aggregators. Get started for free today by visiting snaptrade.com/codestory. Let's flip to scalability. And perhaps, when people think about encryption, maybe they think it's intensive as far as the calculation, or it can be. So tell me about how you're approaching that at Zama, and have there been interesting areas where you've had to fight it as you've grown?
So encryption can be very slow. It can be very slow. In the past, it was very slow. I remember the first browsers in the early days of the internet would take ages to do encryption. So it was a real problem. And in those days, people, especially on the servers, if you were running a website, you would have hardware acceleration on your website because that's the only way you could deal with the security. As time has gone on, that's no longer needed for the kind of encryption that we use on the internet today, like TLS. We don't really need a lot of hardware acceleration. However, homomorphic encryption is a whole different kettle of fish. It's really slow in comparison to normal encryption methods. So we need a lot of performance improvement. So we have a number of ways of achieving those performance improvements. You can improve the performance by improving the algorithms, improving the math. So that's why we employ a lot of mathematicians to improve the math. We also need having performance improvements actually in the implementation of that math, which is why we employ a lot of computer scientists with deep expertise of how you implement stuff in Rust or whatever. And then there's how do you convert a problem instance into the best way of implementing it? So that's actually, in some sense, that's like a compiler expertise. So it's why we have compiler expertise to build homomorphic encryption compilers, which take a user's thing they want to do and then work out what's the best way to do that using homomorphic encryption. That's essentially a compiler problem. We can get performance improvements by using special hardware. So we have expertise in GPU acceleration. And as I said, we also have expertise in hardware acceleration. So that's building accelerators based on FPGAs or eventually ASICs. It turns out there's a bunch of companies around in the ecosystem that are also building hardware accelerators for FHE, whether they be FPGA or ASIC based. And so we're also partnering with those companies to make sure that their products dovetail with our products. On the compiler side, we're also working closely with Google, who have a compiler called the Hare compiler based on MLIR, which is also working closely with our products. So we're working with partners to accelerate, having our own stuff to accelerate, and just having a lot of expertise around. But there's lots of points where we can accelerate.
When you step out on the balcony, you look across all that you and the team have built at Zama, what are you most proud of?
Personally, the team it really works well. It's got a huge number of expertise in different fields. I'm not just talking on the technical side. We have a great marketing and PR stuff. We put on events at conferences and other companies put on events, and always people are talking about the Zama event. So it's just not just, it's the technical side. It's also the marketing side and the engagement side. So I think it's the team. But not in just the Zama team. I think I'm also quite proud of the external team, the ecosystem. We're reaching out to academics working in universities, researchers working in research institutes. And we've created an ecosystem which kind of supports FHE in general. That ecosystem also includes the team of partner organizations, like I said, the hardware vendors, the people in Google building compilers, the people in other companies building other things as part of the FHE ecosystem. That whole team. So it's not just the Zama team, it's the wider team as well. That's a really great achievement.
Okay, let's flip the script a little bit. Tell me about a mistake you made and how you and your team responded to it.
So I wouldn't say a mistake. There are dead ends you go down. With any technology like this, there are various choices you can make. And sometimes those choices lead to dead ends. And so an issue is to identify those dead ends quickly and not spend too long going down that path to the dead end, to try and identify what the blockage is. It might not be that obvious. As I said, we're pulling together a lot of skill sets and a lot of different components in a very complex system. So there's lots of different bits of math that have to work together, lots of different bits of cryptography that have to work together. And sometimes they might not actually dovetail together very well. So it's managing, oh my God, we've got this huge design space. How the hell do we explore it? And when we go down a path, actually we get to a dead end. Do we keep going? Do we hit our head against the brick wall at the end of that alleyway? Or do we just turn around, walk back, and then try a different alleyway?
Well, what does the future look like for Zama, the product, and for your team?
We're going to be expanding into the blockchain space. We've got a number of partners over who are going to be launching products in early 2025. So live parts of the blockchain ecosystem are going to be using Zama products from 2025 onwards. And then the question is building that out. So building out within the blockchain space. Once we've done that, or as we're doing that, we're actually looking at traditional financial applications where we can use the same technology. So 30 years ago, almost 30 years ago, the internet came along, 1994, Originally, the internet had no security because no one cared about security. And then suddenly we have a little bit of encryption goes on. In the first time, it was to encrypt credit card numbers around. So we could just do a little bit of encryption to do a little bit of banking, a little bit of ordering online. But now, when you go to every single website, it says HTTPS at the very top of the website. And that says your communication with this website is secure and it's encrypted by default and everything is secure by default. Okay, so that's where we've got to after 30 years of the internet. But a lot of stuff on the internet and a lot of data, not just on the internet, but just in computing in general, is not encrypted. You always see these things about data breaches. And why do we have data breaches? Is because companies need to store data in the clear because they need to process that data. You have a database, you store the database encrypted, but then when you want to process it, you decrypt it. Now, wouldn't it be great if all of that data was encrypted all of the time? And so in some sense, the long-term vision is to take all of the data and encrypt it so it's encrypted all of the time, even whilst it's being processed. So in some sense, we've gone from HTTP to HTTPS. So in some sense, we're trying to create something like HTTPZ, the Zama HTTP, where all data is encrypted. And then we don't have to worry about data breaches again. We don't have to worry about privacy because all of our data is private by default because it's decrypted by default.
Let's switch to you, Nigel. Who influences the way that you work? Name a person or many persons or something you look up to and why.
Very early influence of mine was a guy called Scott Van Stone, who died a few years ago. Scott was a mathematician in Canada, and he founded a company called Certicom, which developed elliptic curve cryptography, which elliptic curve cryptography is the cryptography you use by default now on the internet. You use it in your website, you use it on your mobile phone, it's everywhere. But when Scott Van Stone was creating this technology, it was back in the early 1990s, and no one was using it. Everyone was using other stuff at that point. So Scott was a visionary, he was a mathematician by training, and he set up a company called Certicom, which tried to promote this tech. And now this tech is used everywhere. And Scott was a very early influence on my development as a cryptographer.
Nigel, last question. So you're getting on a plane and you're sitting next to a young entrepreneur who's built the next big thing. They're jazzed about it. They can't wait to show it off to the world and can't wait to show it off to you right there on the plane. What advice do you give this person, having gone down this road a bit several times and advised folks that are doing the same thing? Tell me what you would say.
I came from academia, and so it's the same question you ask students when they're trying to explain something to you, or when you're going to a conference and you've got a lot of boring talks in front of me. The one question you've got to answer very quickly is, why should I give a shit? Because basically there's so many things out there that are competing for people's time and attention, or investment dollars, their dollars in terms of what products they're going to buy, or the improvements they're going to make. If you're in a company, you've got lots of companies, startups coming to you going, use my new shiny whizzy thing. It's better than that other company's shiny whizzy. All of this is basically, tell me why I should give a shit. And if you can answer that question quickly, then I think you're halfway there. What is the problem you're trying to solve, and why is it a problem to me? Why should I care?
I think that's a fantastic question and a great piece of advice to lead them down towards why should they care? Why should you care? And why should anyone care? Well, I appreciate you being on the show. Nigel, thank you for telling the creation story of Zama.
Thank you very much.
And this concludes another chapter of Code Story. Code Story is hosted and produced by Noah Labhart. Be sure to subscribe on Apple Podcasts, Spotify, or the podcasting app of your choice. And when you get a chance, leave us a review. Both things help us out tremendously. And thanks again for listening.